Afternoon, everyone. Welcome to today's expert dialogue session on using big data for price statistics. I'm Yan, co-chair of the ESCAP steering group of the Regional Program for Economic Stats. Big data is not new, and the demand for the further usage of big data for price statistics remains high, prompted by the increased digitalization of retail businesses and the high cost of price collection using traditional methods. Therefore, it is timely that the steering group has organized today's expert dialogue session on this topic. Before we start, may I invite Ms. Vicky Hansen, Chief of Economic and Environment Statistics of the ESCAP Statistics Division, to make official opening remarks. Vicky, please.
Thank you so much, Ms. Yan, and a warm welcome also from me to everyone who's listening in. I'm very happy to see that there's a long list of people in my list here on MS Teams. So thank you so much for setting aside an hour and a half to join the community today. Now the topic of today's dialogue is very much something that's speaking into a broader agenda for statistics development that we have all been part of for some years now, and that is the transformation of national statistical systems to meet increasing and shifting demands for data and statistics. This is a discussion that really took off in the context of developing the 2030 Agenda for Sustainable Development, but it has stayed with us. And at the very heart of this discussion all along has been big data in all various shapes and sizes. And this is also something that was picked up by the chief statisticians in Asia and the Pacific when they met last time, which is almost 2 years ago. But they did identify the enhanced use of big data for official statistics as a priority topic and asked all of us to accelerate our efforts to progress this particular type of data and very promising type of data. We all did what we could in different groups and in our own workplaces, and it was very good to see that this particular priority topic was also picked up by the steering group of the Regional Program for Economic Statistics, today represented by Ms. Yen, who is co-chairing that group. They included big data for economic statistics as a priority in their program for last year and this year, and that has led to a series of stats cafes as well as the dialogue we are having today. At the same time, at ESCAP, we also took some steps to find out what was really going on across the region we all work in. And we produced and published a series of knowledge products and briefs and found that there is a lot of experimentation going on in Asia and the Pacific by statisticians throughout the region to experiment with big data, finding out whether this data source can be used for the production of regular statistics. The mapping and documentation of these examples is available for all of you to have a closer look at. One of the central briefs in this series of knowledge products was one on the use of big data for economic statistics, so broader than price statistics, but including that as well. And we found that this particular topic of statistics was really at the forefront of using big data. This is where we found examples where statistical offices have gone beyond the experimentation phase and now included different types of big data for the regular production of statistics. We also saw across the board that for most areas, we are still at an experimentation stage, and the common challenges that everyone was highlighting related to legislation, data governance, and partnership arrangements that are necessary for statistical officers to actually dig into and make use of big data. So we organized a dedicated expert group meeting last year. It was in the virtual world, a series of virtual discussions and stats cafes where we dug a bit more into what could we look at as successful models for partnership arrangements and legislation that really enable statistical officers to progress on this journey. The specific stats brief that I mentioned, Big Data for Economic Statistics, is linked in the invitation to today's dialogue. And I do encourage all of you to have a closer look, if not at all the different knowledge products, then at that particular one. You will see a number of different examples documented, also specifically on price statistics. The work that has been done by the steering group on economic statistics, as well as a number of other groups that are functioning in the region, has been of inspiration already to the chief statisticians in the region. They are meeting again in a few months from now, and they have put one of the central topics, the data governance topic, as a priority issue for discussion in August. So we can all expect more to come along this pipeline of activities. This concludes my welcome, but before I hand back to our host and moderator of today, Ms. Yen, I want to thank her personally and the steering group broadly for being very active in sharing experiences across the region to help everyone help themselves to experiment further with the use of big data for economic statistics. I want to also thank my colleagues, Alec and Ing, who are the ones who made it possible for all of us to meet virtually today. So thanks very much. And with that, back to you, Ms. Yen.
Thank you, Ricky. We will have about 20 minutes each for each presentation. If you have any comments or questions, please feel free to post them in the chat box. At the end of the 3 presentations, the presenters will answer the questions. The first presentation is by Dr. Dunstan on the use of big data in price statistics. Dr. Dunstan is a data scientist with over 10 years experience in both traditional statistics and modern machine learning methods. Currently, he works as a data scientist at the World Bank Group headquarters in Washington, D.C. Prior to this, he completed his PhD at the University of Tokyo in 2016. His PhD research focused on using machine learning methods to explore insights from mobile phone data, and his passion includes contributing to the modernization of official statistics in developing countries with the use of alternative data sources such as mobile phone data, as well as improving capacity in data science. Dr. Dunstan, over to you, please.
Let me see if I can share my screen. I'll try to share first. If I cannot share, then I'll share the presentation with you. It's in Google Slides, but I'll try to share first. So are you able to see my screen? No, not yet. Okay. Still no?
No, I don't think we can.
Okay, so Ali, I've shared with you the link to the presentation. Can you open it?
Okay, just a second. We can see something, but
oh, you can see something?
yeah, we can see something on your, yes.
Can you see the slides now?
Yes, it says big data for economic statistics, exploring alternative data sources in modern science methods. Is that the one?
Yeah, so I'll put it in slideshow mode.
Yes, that's perfect. Please go ahead.
Okay, all right. So yeah, thank you very much. My name is Dunstan, as introduction mentioned. So I'm very glad to make this presentation and to share my experience. So just to a little bit of an apology that the focus is just going to be in economic statistics in general, although initially I thought I would focus specifically on price statistics. So I think I'll not take a lot of time on my background. I think the moderator has already mentioned on my profile. So currently I'm a data scientist at the World Bank Group in Washington, DC. And I focus on helping the teams at the World Bank to utilize big data methods as well as alternative data sources. And this is what I'm going to share today. So by now, I think almost everyone knows what's big data, but I'll just briefly mention what I mean by big data in my case so that we are all on the same page. I'll focus a lot on mobile phone data and web scraping, and just at the end, briefly mention some of the other potential applications of machine learning or big data in economic statistics. So of course, this is a question. It's still important, I think, to address this question of what is big data, simply because it's a very big buzzword, and I think we talk a lot about big data in some cases without necessarily agreeing what it means. So in these presentations or in the context of official statistics, for me, I often refer to big data as consisting of two things: whether we are using alternative data sources or opportunistic data sources, or in some cases, we're also using what I can call modern data science tools or methods, for example, like machine learning or deep learning. So in either of those cases, we can call it big data, or that's what I'm calling big data in this presentation. So again, just to emphasize that big data can either be just the alternative data sources, or when we're using methods which are not traditionally found in official statistics. So for example, like when we're doing web scraping, or when we're using methods like deep learning, which are not often used in traditional statistics. When it comes to alternative data sources, so we can have like mobile phone data or social media data or different sensor data that we can find. So of course, the focus is on economic statistics. I have to say I'm not an expert in economic statistics. I have background of working at the National Statistical Office back in Malawi, but I was in the demography and social statistics section. But I do have some idea of some of the main areas of economic statistics, and that's what I'm going to talk about. Before I get into the details of the presentation, so what I'm going to do is to share the work that I've done, and that work has, some of it has direct applications in economic statistics, but also I think it can be used as an inspiration. My experience can be used as an inspiration for some on exploring some of the applications of big data in economic statistics. So those are the, so mainly I'm not going to get deep into one specific project, but provide more of a survey of the work that I've done on use of big data as it relates to official statistics. So because of this, I encourage you to ask any questions at the end. So I'll try to be brief during the presentation so that maybe we have more time to discuss. So I'll start with my work on mobile phone data. And this is one of the areas where it doesn't necessarily have very direct applications in economic statistics, but I'll just share some of the work that I've done in use of mobile phone data in the context of the work at the World Bank Group, as well as I've also participated in some expert groups on use of mobile phone data for official statistics with some colleagues from the UN. Of course, the first questions to address is just what we mean by mobile phone data. So I also call this is some kind of like approximate residence history. That's how you can think of it. One example of mobile phone data is what's often called CDR. I think that's what most people are familiar with, I guess, in the meetings. So it's essentially the calling records when we use the mobile phones. So this is generated by the cellular phone company. And what I'm showing here is just an example of the mobile phone data where we have the anonymized user ID, we have the timestamp, we have the cell ID, and we also have the geographic location. And for almost all categories of mobile phone data, the most important thing is actually the timestamp and the location. That's what is used mostly. Some of the benefits here, just comparing mobile phone data versus like survey-based data or field-based data collection is, of course, like for mobile phone data, it's easy to process the data frequently. So the temporal frequency, it's much, you can process the data, so for example, every 3 months or every month because it's easier to access the data. So that's one of the advantages. But one of the disadvantages, of course, is this type of data is not collected specifically for, let's say, generating tourism statistics, as I'll show. It's collected for like billing purposes for these companies. So the data is not super accurate as compared to, let's say, survey data. And when I mean mobile phone data, there are several sources. So some of it can come from, as I said, CDR, it comes from cellular network companies, but some of it also can come from GPS-enabled smartphones. And there are lots of applications, of course, for this, as I'm showing here. So I just want to show one project that I've done on using mobile phone data in transport, just to show some of the issues and my experience on using this data in like a real life project. So I'll quickly switch to PowerPoint slides just to show this one. I'm hoping not to. So one of the projects I've done with using of mobile phone data is to generate mobility indicators. So these are indicators for a transport project. In this case, the project was done in Sierra Leone. And that the analysis goes like for this transport type of project is usually to generate what are called origin destination matrices. So for example, like given two locations A and B, how many trips are happening between two cities or two towns or any two locations? We also want to understand the individual level mobility attributes, like how far does an average person travel every day? So we call this like radius of gyration, for example. So from this, we can determine like how developed the transport system is. So these are some of the typical like analysis objectives for when we're using mobile phone data for transport project. For Sierra Leone, this animation is just showing like what we can get from mobile phone data. So this is again in Sierra Leone, and you can see how kind of easy we can visualize the mobility, and that we can see that the capital city here is in Freetown. So that's kind of like in a nutshell what we get from mobile phone data, this kind of ability to visualize the mobility of people. In this project, of course, we had access to data from 3 operators in Sierra Leone, but I will not get into the details. I just want to show some of the results. So for this data that we had access to for one telecom companies, so we had data for January for 4 months, as you can see. So it's usually a lot of data. So it's around 2 billion like records or cell phone records for about 6 million unique subscribers. So this is just a basic summary of the metadata for this mobile phone data. And I don't want to go into the details of like how we generate the origin destination matrices, but this is just showing some of the methodology for processing the mobile phone data. Some of the things we try to do is to estimate which is the home of each of the individual in the data set, as well as their workplaces. So one of the asks from the transport specialists actually is they want to understand the attractiveness of each location in the city, if we can estimate whether it's some type of doing like land use classification. So given the mobile phone data, can we use it to estimate or to approximate which region is mostly like for commercial purposes, or where people go to work, and which regions are like residential. So this shows some of the user characteristics for this data set. And again, as I said, these are some of the indicators that we can generate from this, like location, number of locations visited per day, number of trips which are done per day, and so on and so forth. So another thing when you're using the mobile phone data, of course, is it's important to validate the data. So what you see here is just trying to get an idea of the correlation between the subscribers in the data set for one telecom company versus the population. So the correlation coefficient is like 0.6, which is reasonably good. It's not super excellent, but at least it's good enough to show that the data coming from this single operator at least is reasonably representative, or it matches with the population data. So I'll just go back to my slides on Google. So that was just an example of a project on using mobile phone data for transport. And here's a paper based on that work. So there's a link to this paper when I share the when I share the presentation, you'll be able to look at the detailed work that I did in, which is in this paper. Another work I've done, and I've just linked the paper here, I'll not go into detail, is also using mobile phone data. As you may know, it's being used a lot in the case of monitoring COVID-19 and trying to understand people's mobility as it relates to the spread of COVID-19. Finally, I think probably since this is UN ESCAP, you're most likely familiar with this work. I think it's an example where a statistical office has almost integrated the use of mobile phone data in generation of official statistics. So in Indonesia, I think they're using mobile phone data for generation of tourism statistics. And there are several examples of using tourism statistics from mobile phone data. And I guess tourism statistics is not necessarily economic statistics, but I think it forms input into some of the economic statistics. So that's kind of it on use of some of the projects I've done on mobile phone data. And I want to quickly move on to another aspect of big data, which is web scraping. So this is more on the methodology. And I guess you can also think of it as alternative data source, since we're trying to extract data from websites rather than what we usually do in NSOs, like conducting interviews. So I'll talk about what we mean by web scraping, and then move on to several examples of web scraping projects that I've done. So web scraping is simply just extraction of data in an automated fashion from websites. So that's the basic definition. In some cases, actually, so web scraping is pretty popular, and I'm sure many are familiar with it here, but in many cases, it's straightforward, but it can also be difficult and challenging. So I wanted to share one case of a web scraping task that I did at the World Bank, and to just quickly show here that this is reasonably related to economic statistics, but the task was to get some data on firms or on businesses. So given a list of businesses, so this was my client within the World Bank. So they're giving me a list, or they're giving us a list of firms. So what they wanted was to enrich this data. So it's just a list, mostly just the name of the firm and the country where that firm operates, but they wanted more data for that firm, like what products do they sell, which countries do they sell it to, who owns the company. So that was briefly what the task was. So this is not, it's slightly different from a typical web scraping task. So that's what made it challenging and difficult. So it was impossible to solve it like with standard web scraping, where you only have, like, you have a website, you know where the data is. So in that case, it's straightforward. But in this example, it was very challenging actually, because we only have the names and we have to find extra data for these firms. So
then sorry, we are running short of time. You may have to move more quickly. Thank you.
Okay. So yeah, this is an example of a difficult web scraping task, but the idea was to use like Google Places API and to use like Amazon mechanical text. So let me go back to my slides. I think I'm short on time. So another web scraping task, I think I'll just skip the details here, is I had another work where the task was to scrape data from 100 countries just to understand the reporting on debt statistics. So for each country, the task was to go to their Minister of Finance website or the National Statistical website and find out how much they are reporting on their debt. So again, it was another challenging task because there are 100 countries with different websites, so it was difficult to do the web scraping. This is an active task that I'm doing. It's also a web scraping. So in the due to the conflict in Ukraine and Russia, so there's of course like urgent need to try to understand the flow of goods, the status of trade within these countries. So as you can see here, the task is to scrape data from this website. This, again, some of the challenges here are kind of similar. So the data is presented as interactive websites, so it's not easy to scrape data from here. But we can use some tools in Python to still get it done. Finally, so I just wanted to mention some other potential applications of big data in economic statistics. So at the World Bank, some of my colleagues are working or doing experimentation on this. So for example, Maurice is working on use of computer vision to get price data from images. So think of like sending people to just take pictures of people selling goods and then automatically extracting data from those pictures. There's work by Jean-Francois on creating logistics performance indicators, which they're also related to economic statistics using big data as well. And so these are the examples of also like estimating house prices, in this case using web scraping. So these are in both cases experimentation which are currently happening at the World Bank to change some of the indicators or metrics to start using big data. So let me stop there. I cruise through because of time, but please, if you have any questions on any of those projects, feel free to ask at the end. Thank you.
Thank you, Dr. Dunstan. So if you have any comments or questions on the presentation, please feel free to post them in the chat box. Okay, now we'll move on to the second presentation. It's by Ms. Frances Krosnick on multilateral application pipeline for consolidating big data prices, methods, and processes. Frances is a principal analyst in the prices unit at Stats New Zealand. She has worked in official statistics for the last 25 years, first as a survey methodologist and then in inflation measurements, with a particular focus on the development of new methodologies for estimating prices from non-traditional sources such as scanner data, web scrape data, and admin data. Frances, over to you now.
Thank you very much. And this is probably a good order in a way because the focus of my talk is really about once we've already got the data, how do we try and create price indexes that will compare with similar concepts to our current CPI, Consumers Price Index, or potentially overseas trade index or house price indexes. So it's really about when we're at that stage past the point where we've done all the collection, what are the issues that arise? Now, can you see my screen okay? I'll assume that that's all okay.
We see it clearly. Thanks, Frances.
Okay, great. So I'll go back up there. So really the focus of my talk, I'm just going to set my timer so I stick to my time, is that we have been using what you might call big data, or perhaps more properly, as Dunstan pointed out, alternative data for price statistics at Stats New Zealand. It's not really big data, it's what you might call bigger data, in that it's much bigger than traditionally used for price measurement, and so we require new methods and processes. So we've been using this kind of data increasingly over the last 20 years, and so it's good timing now to talk about the stage that we're in, which is kind of a consolidation of existing practice. We're doing some housekeeping, tidying up, improving, generalising what we're already doing and looking to the future of how we can make more use of these kinds of what you might call either non-traditional or alternative or big data sources for price statistics. So in particular, we're talking about data sources like scanner data. So the data that results when you go through a supermarket checkout. And so there's information collected through that scanner data on exact prices being paid for every product that's actually going through that checkout for full universe of products. So it's very rich data source. So scanner data, administrative data sources like say tenancy bond data is one that we use for rent price indexes. Transport authority information on registered cars, customs data coming in and products coming in and out of the country, web scraped online data. Again, Dunstan talked about that. So these are all data sources that we can make use of, but they all come with challenges. So just going to move this little box out of the way. So I guess the key messages that I want to get across today is that our use at Stats New Zealand of prices big data has increased and evolved since 2001, and now we've got quite a few different data sources that we're making use of. And there's been a lot of focus on methods for estimating price indexes from this new kind of data because it has features which mean that traditional methods break down, don't work properly. But alongside the issues of what methods to use for index estimation, we've had to deal in production with various aspects of the data itself, and this is very much kind of linked to the fact that big data is so big that you often can't really see what's happening in it. So while you might have quite reasonably sort of manual processes that are realistic to be applying for, say, quality adjustment when you're pricing just a few specifications of a product, say a couple of models of computer, and you have to replace them with another model of computer. If you're only doing 2 or 3 of those, then it's quite reasonable for an analyst to make judgments about how to compare those 2 models of computers. But if you've got 2,000 models of computers and you've got automatic capture of the prices and quantities being sold, then you can't do things in a manual way. You've got to automate it. So the methods, to a certain extent, the new methods deal with that to a certain extent, but there's also other production processes alongside the sheer size of the data and the need for everything to be automated that kind of rear their head and that we need to deal with in quite a automated way. And so over time we've developed production processes that we're now trying to sort of surface and generalize and talk about in a way that will be useful for other stats officers that deal with the same kind of issues. So I said before, we're now consolidating our production process with development of what we're calling our multilateral application pipeline, which is a system that we're building in R, the open source programming language. And the MAP itself is built around an R package called Multilateral, which is just today actually has been lodged on CRAN, which is and I had to look this up before, the Comprehensive R Archive Network. So it's an open source platform where you can download this code and use it yourself. So that's the index estimating kind of kernel of a wider system that we've built, or that we're building, sort of iteratively building at Stats New Zealand, called the Multilateral Application Pipeline, which is our system for ingesting the data from a lot of different alternative sources, standardizing it into a format where we can then feed it through the index estimation system and be quite flexible about exactly what methods we use, and then produce diagnostics and analytics out the other end. Go down. How do I do that? Right. So many of you who are familiar with price measurement will know that one of the big challenges is quality change. So to produce price indexes, we need prices, quantities, and some measure or way of controlling quality, and that's the big challenge. So traditionally we deal with this aspect of the challenge by having a fixed basket of goods that are representative of what consumers are actually buying, and by pricing just that fixed basket between periods, that's how we make sure that we're comparing like with like over time. Between basket updates, which might be, say, every 3 years, there may be products that were being sold that are no longer being sold. So again, a particular specification of computer, say, so we need to replace that specification of computer, and there'll be judgment or some kind of analytics employed to make some kind of adjustment for whether this new computer is, say, twice as good or the same level of quality as the one it's replacing, and then the price difference will be adjusted for that change in quality, so that we're not so that we maintain our sort of like for like comparison over time. So that's traditionally how it's done. But in the case of big data such as scanner data, where we're getting prices and quantities for thousands of, say, models of computer, for example, it's no longer relevant or feasible for us to use a fixed basket. And I'll go on and tell you a bit more about that in a few slides. So I think at this point we could kind of point out that there's both challenges and opportunities with big data for price measurement. So quality is changing. Quality of products is changing a lot faster over time. The product universe is more dynamic. So this means price measurement is getting harder, and that it's harder for us to hold a fixed basket and measure it over time. But on the other hand, more and better data is available. So price measurement potentially is going to get easier and or better. So, you know, we have two conflicting kind of directions happening there with the sort of increased technological pace of stuff going on. And I'm just going to show you here, this is a graph showing when we were looking at bringing in scanner data into production to measure consumer electronics products. So this analysis is showing I think it's 8 different consumer electronics products, so camcorders, desktop computers, digital cameras. This is saying for those models of goods that were available at July 2008, this is showing you what percentage of those models were still in the market, still being sold month by month from that point on. So what you can see there is that laptop computers, which is the blue dashed line, has got very, very high what we would call churn. So a year after July 2008 and July 2009, around 10% of the models of laptop that were being sold are still being sold. So in other words, if we were to have fixed our basket based on the models being sold at the start of this time period, it would be almost completely out of date 2 or 3 years on. What this means is that we can't use a fixed basket and then use what we call bilateral indexes, where we just relate back to that basket at that point in time. So then, okay, we probably need to backtrack a bit here too. So why isn't it straightforward to use big data for price measurement? So although we have, from the big data like scanner data, we have updating information on weights or quantities being sold, which means that we can use chained indexes. So we could update our basket from period to period and just calculate an index from, say, time 0 to time 1, from time 1 to time 2, based on an updated basket in time 1, from time 2 to time 3. So although that would be the obvious way to deal with that high level of churn, the problem we have is that unsymmetric price and quantity spiking or volatility due to sales, which happen more and more regularly, as you're probably aware, causes what we know as chain drift and high frequency chained indexes. So in other words, Traditional index methods break down for this kind of data. The other issue is that we need to somehow reflect the quality change associated with the introduction of new products. So the methods need to somehow account for any implicit quality change that arises with that introduction of new products. So, this is just showing you, This is just showing you an example of what I was talking about with this asymmetric price and quantity spiking. This is a graph that got used quite a while ago by Jan de Haan and I'm not sure of his first name, Van der Grint, looking at some pharmaceutical tablets. So this is scanner data and it's showing in a very kind of high frequency way the unit values or average values of these pills, and at the same time the quantities being bought. And so you can see there's big spikes downwards which correspond to these things being on sale, and at the same time obviously people are buying lots when they're on sale. The issue is that the way that those prices spike down don't exactly mirror the way the quantities spike up, and that means that chained indexes will start to drift apart, which is why we can't use them. So the solution is to use what we call multilateral indexes. I'm going to speed up a bit here because I realise I've got a few slides to get through. Multilateral indexes are indexes that use a lot of periods of data within what we'd call an estimation window, which would generally be a year of data at the minimum. So it could be 12 or 13 months of monthly data, could be 5 quarters. We usually do a year plus a period. So 13 months of monthly data, 5 quarters of quarterly data would be typical. And it differs from the traditional approach, which is to use bilateral indexes where you're using just a base period and a current period. So you might either be calculating your index with the prices and quantities of your base period and now, or it could be that you're chaining together from base period to time 1, time 1 to time 2, but you're only ever using prices and quantities relating to 2 periods. So there's 2 main forms of these kinds of multilateral methods. One, for example, and the famous version of it is called the GEX or rolling year GEX, combines together multiple bilateral indexes. Bilateral, also superlative. Superlative means you're using prices and quantities in both the base and current period. So they tend to take an average of a whole lot of these bilateral indexes within an estimation window, and that's done in such a way that issues like this chain drift thing I told you about don't occur, and that's a sort of theoretical consequence of the way the index is formed. The other main way of doing these is using regression-based, what we call hedonic methods. So these are really fitting statistical models to the data and modelling price against time and the characteristics of the goods. And combination of these 2 approaches is an example of a combination of those 2 approaches is this one called ITRA-GEX or Imputation Tornquist Rolling Year GEX. This is what we used in New Zealand to this is what we use in production to produce price indexes for consumer electronics products from scanner data. And another issue is that the non-revisability constraint of a CPI, Consumers Price Index, means that we need to also add in what we call a splicing component to the methods, which enables it's kind of a revisioning factor to be incorporated with the latest movement. I'm not going to go into detail with that, but I'm going to give you references at the end if anyone wants to go into any of the detail. So this is showing for a consumer electronics product. This is digital cameras. This is showing how volatile and how seasonal the data can be. So this is the scanner, from the scanner data, this is showing the solid line is total expenditures over time, monthly. Quantity sold is the dashed line, and that blue line is average price. So total expenditure divided by quantity sold. And what you can see there, interestingly, is that there seems to be a bit of a seasonal dip, which corresponds presumably to people buying cheaper cameras around Christmas time. Maybe they give the cheaper cameras to each other as gifts and then buy the more expensive ones in the rest of the year. But anyway, so there's a sort of seasonal pattern in the unit values or average prices. Now, this is showing, the blue is the same average price, but it's on a different scale. So you can see the seasonal patterns more markedly. So this is showing when, after applying the imputation Tornquist rolling year GEX index I talked about, this is the quality adjusted price index. So this is the kind of measure we want to see. If we were using just average prices on that data, it would be biased upwards and it would be highly volatile in a way that doesn't actually reflect quality adjusted price change. So I'll just check my time. I'll speed up a bit. So over the last 20 years, we have gradually incorporated a number of different alternative data sources for price measurement, starting in 2001 for used cars. Actually, this was based on survey data, but we used one of these multilateral methods that I'm talking about to get a more efficient and accurate measure of price change based on that survey data. 2013, we put what we call a time product dummy method into production for TVs and mobile phones. This was for our overseas trade index using customs data. Then in 2014, we started using the scanner data for the consumer electronics that I've talked about. 2019, we introduced the use of tenancy bond data. We started using scanner data for supermarket products, but strictly in a substitution method. So we're using our current fixed basket. We found the relevant products in the scanner data and substituted them in. The reason we did this was that we weren't able to get quantity data from the supermarkets. Since then, we've recently gained quantity data from one of the main supermarkets, so we intend to make full use of the supermarket scanner data over the next year or so, once we can hopefully get quantity data from the rest of the retailers. And in 2020, we also started making full use of customs data for the overseas trade index using a time product dummy method. So we estimate, I think, around 300 indexes for the OTI using customs data. So that's all automation. That saved a lot of time in production. Okay, so why else isn't it straightforward to use this data? It's hard to see what's going on with big data. We have less control over changes that can happen in the data, and it can be hard to gain insight into what's causing movements. And doing things at scale, so in really large kind of large scale way, means it all has to be automatable, but in a way that is transparent and safe, where it doesn't become like this black box where we can't see what's going on. So alongside generalizing how we do the index estimation side of things, so the running of these multilateral methods, we've also trying to generalize and consolidate the way that we actually do the production processes around the edges of that index estimation. So this is in terms of things like checking input data, descriptive statistics, coding of data, which can change over time. So the suppliers can change the way that they code things, looking for outliers, producing decompositions of indexes and enabling points effects analysis. And this is an example of the kind of thing that we produce. This is showing number of new product IDs, so the number of new distinct products that are coming in each period compared to the number that have come, number of new products in the past. So at a glance, you can see across 10, I think it is, 10 different consumer electronics products, whether anything's sort of out of the usual range of variation with that. I'm going to whiz over this because I've gone over time. But I will say that the multilateral package that we've developed in-house, which is borrows heavily from Graham White's index num-R package for some of the underlying functionality like GEX, but it also incorporates other methods that we use here at Stats. And we've part of why we've written it ourselves is to have that kind of control and transparency over having built our own package, but also it's important to us for it to run quite fast because of what we're doing with it. So there's been some functionality added to enable it to run in parallel using kind of parallel cores or something. I'm not really a developer, so I'm probably saying this wrong. And also optimizes has optimized functions like sparse matrices and memory efficient operations. I'm going to whiz over that. But yeah, basically the multilateral package fits inside this wider generalized system. This is showing the wider generalized system. So there are many opportunities for better, and by better we mean faster, cheaper, more accurate price measurement from big data, but there are challenges both in terms of the methodology and production processes, many of which we've had to deal with over the years and develop kind of solutions for. The methodology side of things is largely solved. There's still research on the details of that, but in terms of index methods, a lot of work over the last few decades has been done on that, and that's largely sorted. We're all facing some similar issues, so collaboration and sharing is really important. Thank you. And if you're interested in reading more, I'm giving you here a link to the most recent paper we wrote about all this stuff. And also, if you would like to use, improve, change, comment on the multilateral R package, you can get it from CRAN. Thank you very much. Now, how do I get out of here?
Just go to share, stop
there you
sharing
go.
somewhere. Perfect.
Okay, thank you, Francis, for your presentation and the references. We'll move on now to the third presentation. The third presentation is by Mr. Riza Hadizada on the application of text mining techniques to improve the dataset integration in foreign trade price indices. Mr. Riza is group leader on the SPPI unit of the Statistical Centre of Iran. He is the PhD candidate of Industrial Engineering and has been working in Iran's NSO since 2013. Mr. Riza, please.
Thank you. Hello, dear audience. I'm going to talk about using text mining to encode records in registration data. There are please, next slide. There are two notable challenges in price indices. We want to use registered data, and especially when they are big data. First, inaccurate calculation of price indices, and second, no harmonization between merchandise description. As in recent years, we see the different diversity and speed of information production in various fields, including official statistics. The use of a new statistical method to modernize the process of producing official statistics, including the process of producing primary data and secondary data, are essential. Due to the fact that the creation of statistical records is in line with the modernization of statistical system. In this presentation, the use of text mining to automatically encode the registered data in customs of Islamic Republic of Iran for a more accurate calculation in this in the field of price index in the goal. Price indices in official statistics is one of the most important production statistics. And the price index is used to monitor price changes and inflation. The exact calculation of is very important for government and economic planners and policymakers. To calculate the price index and accurately calculate price changes, each statistical item with fixed future should be counted during statistical periods. And if these futures are not fixed during a statistical period and change, the calculated changes are not only the result of price changes. These changes can be the result of product quality. Since the records registered in customs are based on HS classification, and each HS code, whether at the level of 6-digit or at the level of 8-digit, contain several homogeneous goods. The export price index and import price index is calculated, and the price changes would be as a result of a change in quality, not a change in price. Therefore, there is the challenge of accurate calculate the export price index XPI and import price index MPI based on custom registration data. Our proposed method is use text mining of description of goods and to create a new coding system of registering records. Please next slide. And calculation of changes. The harmonized system is an international nomenclature for the classification of products. It allows participating countries to classify merchandise on a common basis for custom process. At the international level, the harmonized system HS classifies merchandise trades into a 6-digit code system. The HS comprises approximately 5,000 article or product description that appear as headings and subheadings arranged in 99 chapters grouped in 21 sections. The 6-digit can be broken down into 3 parts. The first two 2-digit HS2 identify chapter, and next 2-digit HS4 identify groupings, and next 2-digit HS6 are even more specific. Up to the HS6 digit level, all countries classify product in the same. Please next. In this slide, we decide to talk about text mining process. As you see in the table, there are three steps. The first step is pre-processing. In the step contain action of removing number, puncturing, stop words, strip white space, and stemming. Second step is estimation of similarity between merchandise description. Text similarity measure play an increasingly important role in the text-related research and application in tasks, such as information retrieval, text classification, document clustering, um, topic detection, and so on. Finding similarity between words is a fundamental part of text similarity, which is then used they use as a primary stage for sentence, paragraph, and document similarity. Words can be similar in two ways, lexically and semantically. Many methods have been introduced for similarity findings into different texts. Two famous methods is Jacquard similarity and cosine similarity method to find similarities between two texts. The third step is the creation of the library for new coding to boost the likelihood of matching between the new and old data and remove mismatching. Please next. For creating link between the custom register data, there are two challenges. First, Iran's custom data set is a large data set. More than 400,000 records are received on a daily basis. And this makes it impossible to eye control and review the data for inconsistencies um, between the customs attribute set description between one period and another. The other issue is the redundant characters leading to inappropriate matching. If the matching process is done with only consideration of the 8-digit code, the calculated indices will be misleading and inexact. Commonly, each code's description contains a series of characters, including but not limited to numbers, symbols, low importance signs, redundant space. Yes. In order to prepare a high quality analysis to this code description, it would be necessary to remove these characters, such as punctuations, numbers, stop word, and white space. Last step is stemming. Stemming is one of the prominent steps in text mining techniques. Please next. It is worth mentioning that unqualified data matching based on merchandise descriptions is one of the immense challenges for precise calculation, MPI and XPI. In customs data in Iran, technically linkage with the only merchandise description or attribute set, such as tariff code, the value in US dollar, and Iran's currency real, weight, country of origin, transportation type, data of arrival, and average of exchange rate. can result to miss some important data, while in price indices calculation, the important parts are the specific merchandise attribute and stability of considered merchandise during the specific period. In connection with relative price formula, after preposition was similarity verdict of merchandise descriptions for current and last month is necessary for the superior quality of precise. In other words, each merchandise description of 8-digit tariff code in data set uh, in current month should be linked with similar description in data set in last month. The relative price criteria will be similarity degree with at least 70% similarity threshold. Next is, please next. In the final step, and following the similarity determination, a label was appointed to each of record based on tariff codes and keywords in description and the number of repetition of each in the database. This label, however, can be a 4-digit number which can be attached to previous 8-digit tariff codes. The new codes had 12 digits that would be more beneficial for the next linkage. Therefore, a dictionary of frequent attributes, a 4-digit number was added to HS code. In table, the result of the conversion of HS 8-digit to a 12-digit code is presented. This dictionary will be advantageous for further text mining application and similarity identification. Please next. Without text mining, the calculation of MPI and XPI including 2 steps. But to remove the challenges, a new customized coding system should be added. So one step is added to the process. In the step 2, after the data gathering and initial process, the text mining was done between old and new data. Besides, the labeling and library making was done based on the merchandise description. In this step, with entering the new data, the library would be updated. Please next. In this slide, 2 methods of calculation are presented. This method are with or without text mining. As you can see, the difference among some subgroups are notable. Please next. The application of text mining in surveys, generally, this method can be used in cases there is a description for goods and it needed to be classified. For example, in calculation average prices and prices indices. In the coding process, in order to dedicate accurate codes and dividing to subgroup, text mining can be effective For example, detecting 12-digit code in custom based on the merchandise description, and improving the quality of record linkage. By accurate codes and merchandise description, the probability of linear join between two different data sets can be significantly improved. Thanks for your attention.
Thank you, Mr. Riza. Now we can move on to the Q&A. The three presentations today have been very useful and interesting. In the chat box, we have already gotten a few questions for Francis. Francis, I see that you have responded to most of the questions. Would you like to briefly go through with us the questions and what your responses are, or whether you have any other points to add?
Would you like me to go through what the questions and answers were? Is this what you're saying?
Yes, briefly.
Yeah, okay, cool. Okay, so Shuja asked, in developing countries, regulators have roles in price volatility, how to control prices with through the role of the regulator. I said, in answer to that, I said, I think that's sort of outside the scope really of what I'm talking about. And I guess a better measurement of price movement isn't necessarily a less volatile measure of price movement at the kind of level at which we calculate indexes. Yeah, I guess I was looking specifically at volatility in prices and quantities and the effect on the ability of traditional price indexes to kind of cope with that. And I guess I'm arguing that, or I'm pointing out that the new methods that have been developed, the multilateral price index methods, can handle that sort of volatility a lot more effectively than the traditional price indexes. So in that sense, yeah, we're more able to handle volatility. I think the question of sort of controlling at the very macro level, the price volatility is kind of outside the scope of that. Another question. So I'm just scrolling up. And how is seasonality and other data related factors important for big data? So my response to that was really the seasonality of the data means that the traditional index numbers really struggle. So in particular with something like fresh fruit and veggies, which has always been an issue, just determining how to come up with an annual set of weights, or whether you vary the weights across the year, or whether you have fixed weights that are sort of average of the seasonally changing weights across the year. Different countries do it differently. There's no consensus on the right way to do it within that fixed basket approach. The multilateral methods will actually cope with seasonally unavailable products with very strongly seasonal price movements and changes in quantities. So they'll cope with that kind of peculiarity, the seasonal nature of the data really well. Christoph asked about how is the iTrigX method sensitive to estimation errors, and I answered that we use the hedonic regression only for the missing prices in the underlying bilateral indexes. So for all the matched prices where prices and quantities exist in both periods of the bilateral comparison, though we use the actual prices. So we're imputing just for the missing prices or the unmatched prices, and it does rely on having a full set of price determining characteristics. A big focus of our research over the last 10 or so years has been on how well the time product dummy, or as we've called it, the fuse or fixed effects window splice, how well that performs. And the reason we're focused on that is because it doesn't require explicit information on characteristics. It just needs a good product definition. So I've directed Christoph to that paper that I linked to at the end of it. Has a lot of references in there that talk about both the iTriGex and that fuse method that I'm talking about, or the time product dummy. Tika asked about the customs data. I have to admit, I don't know exactly what form that data comes in. My understanding is it's the administrative data we receive from customs on the imports and exports. But there was a paper written about that is linked to in the references, and or you could email me and I'll put you in touch with the team that work more directly on that. I think that was, and Eugene asked, how big is the impact on the index before and after the use of big data? How to use it with confidence. And so my response to that is that in any situations where we've introduced big data or alternative data, we've only done so when we had back data, so historical data, which meant that we could compare the results with our current, more traditional methods and either make sure that they match, or if they don't match, that we understand why they don't match. So for example, with consumer electronics, we had 3 years of back data from the scanner data. We compared what we would be estimating from the scanner data to what we had already got in the, using our traditional basket methodology. They were very close. The scanner data results tended to sit a bit lower, but we understood why that was, because we understood that the methods we were using were doing a better job of quality adjustment than our current, more subjective based field collection kind of approaches. Okay, so that's me. I'll stop talking now and hand over to Dunstan. Question for you in the chat.
Hi, yes. So I was just trying to type my answers for the question from Michael Lawrence. So the first question is on when we're using mobile phone data, whether there are any agreements with the telecom companies and so on. So yes, the data is obviously, it's very sensitive data. It's very confidential. So one of the challenges and the main bottlenecks when working with mobile phone data and just data from private sector in general is accessing the data. So in the case of Sierra Leone, we signed an MOU with the telecom regulator. So there are two options for accessing most of the data coming from telecom companies. One is to work with the telecom regulator, or to work with the actual telecom companies. So it depends on the regulations in the country as well as the willingness of the telecom companies. But in the case of Sierra Leone, I worked with the telecom regulator. There are other cases like in Mozambique where we had two agreements, one with one of the telecom companies, another agreement with the telecom regulator as well. There's another option that we've used as well. In some cases, we have to use third-party organizations. So an example here is, for example, like in Asia, there's the University of Tokyo. They have a team which works a lot with mobile phone data. They have existing data sharing agreements in some of the countries in Asia and in Africa. So in some cases, it's easier to work with these third-party institutions to access the data instead of trying to generate new agreements, just because it takes time to come up with those agreements. So I think I've answered that. Then on the web scraping, yeah, this one is kind of tricky. In general, for web scraping, I think we assume that if the data is on the website, then it's publicly available, so you can scrape it. But in practice, most websites, they come up with mechanisms to block web scraping. So I assume that if you're doing something like scraping price data for pricing, this is something you want to make sure that it works all the time. You don't want it to fail at some point simply because the owners of the website have blocked your scraper. Then it may be necessary to talk to the company and let them know that you are sending your bot or your web scraping crawler to their site, just to make sure that you don't get blocked. So I've had that experience where my script was working today, but after some time it gets blocked and it's not working anymore. So if you're running a project like national scale project on price data collection, it may be advisable maybe to talk to the companies to make sure that you don't get blocked. So there's another question from Angela on how are issues of data privacy and data ethics incorporated in the use of mobile phone data. So yeah, it's a relevant question. So there's several mechanisms, or there are several things that we do at this at the World Bank. So one, of course, is we don't have the personally identifiable information or PII. So when we have the mobile phone data, all the identifiers anonymized, so we don't have access to the actual phone numbers of the subscribers for the telecom companies. So that's one. And of course, some people may argue that even though those are anonymized, there's still some ways to be able to identify. But in the case of CDR data, simply because we are looking at cellular locations, the data is pretty sparse. So the probability of getting or identifying somebody's location is pretty low. That's one. Number two is also in cases where we don't need access to the individual level data, what we're doing is to try to push some of the processing to the regulator or to push it to the telecom company, so that we only access aggregated data and we are not accessing any individual level data. So that's one of the ways to make sure that we are not necessarily accessing that individual level data. And another way is we are avoiding shipping the data from the countries, from the telecom company, to the World Bank in our case. Again, here the plan is, or the idea is to make sure that all the processing is being done either at the regulator or at the telecom company, in that way avoiding that shipping of data, and so reducing the risk of re-identification or any privacy violations. And again, finally, making sure that, of course, we don't publish any individual level data. We don't publish mostly, we don't publish any individual level data. It's mostly aggregated. So I hope I've answered the question for Angela and Michael.
Thank you. I think we can probably take one more final question. If anyone has anything else to ask, you can post in the chat box. So there's a question for Francis. About replacing products.
Just reading that now. Is it harder to replace products when using? Yes. Well, it's different, and I think we need to be very careful. So, the issue with scanner data is that there isn't a clear replacement when we don't have new products emerging as old products exit. So existing products will stop being sold at some point in time and new products will be introduced. But unlike the fixed basket approach, where we almost sort of artificially introduce this idea of replacement products, there's no such thing really in the actual data and actually what's happening in the marketplace as a direct replacement that arrives as something leaves. So the main issue with these multilateral methods is that they have to deal appropriately with the introduction of new goods and with the exiting of new goods. Unlike the fixed basket approach, where there's a real risk that if you don't introduce a replacement product before an old product starts to go on clearance, if you don't get that new replacement product in time, then you can introduce a downwards bias, because you're always kind of you're splicing in the new product at the beginning of its life cycle onto the tailing off of the old product. So there's a real issue with those life cycle effects. Multilateral methods are designed to be able to deal with those kind of issues appropriately. Whether they do or not is still being debated. There's seems to be some recent findings that there might be sort of life cycle or clearance sort of sale effects affecting the GEX index, but that's still being sort of looked at and thought about. So I think it's still a little bit of an open question, but the multilateral methods do in general deal appropriately with products entering and exiting the market. And how do you look into geographic locations in case subnational price indexes are required? Okay, so that's a really good example question. For the consumer electronics situation, we only have national level data, and that is a limitation. So we're imputing what might be happening in store regionally by the national level data. So we're averaging across the regions. For something like the rent price index, which is one where we're in the process of, we use tenancy bond data for that. So it's administrative data on the bond that a new tenant will pay to their landlord to secure their tenancy. We have the data about the location of those rental properties. We're in the process of improving the estimation so that we go from just 5 broad regions down to what we call territorial authority level, of which there's 67, I believe. And so we're using a combination of rolling up data. This is a separate estimate from what goes into the CPI, so we're relaxing the non-revisability constraint, and that will enable us to use more data. But yes, that's very much about it. The sort of the point of those new estimates is that we will have the geographic dimension in those. So where the geographic dimension exists, we'd use it. So for example, with scanner data from supermarkets, I believe we are likely to have geography on there, so that would be incorporated. I think that's the questions for me. Thank you.
Thank you. I think there are no more questions. Participants, if you still have other questions, you can feel free to approach the organizers. I'm sure they will try to put together something for you. Okay, so with no other comments, I would like to close today's dialogue. Thank you everyone for attending today's session, and a very big thank you to the 3 presenters. Yeah, I'm sure the sharing today on using big data, not just in price indices, but in economic stats, will further inspire us to further explore using big data for compilation of official statistics. That's all that we have today. Yeah, the presentations will be made available online, and the resources through. Yep, that's all we have. Thank you very much for your attendance.
Thank you very much. Bye.
Thank you, everyone.
Thank you. Bye.
Bye.